Hello, everyone. We're going to do our quick video from our first lesson in Unit 3. This is going to be about scale drawings and dilations. So a dilation is a type of transformation that can occur where we change the size of a figure while keeping its proportions the same. So many of you all may have had an eye exam before where maybe you've had to have your pupils dilated, which that allows um, the optometrist to kind of see into your eye a little bit better, see through your pupil a little bit better. Again, it just changes the size, but again, it stays the same proportion. Um, that can be seen pretty easily by like this diagram that we have right here, right? If we have this original image, it's kind of this hippo kind of facing forward. It's kind of a funny shape, right? We kind of see the teeth and the eyes and whatnot, little tail, right? The figure A is not a dilation, right? You can see how it's smaller, but it's like smushed, right? That is not a dilation. What would be a dilation would be something like B, right? It's a smaller version, um, but it keeps the same proportions, right? It's just kind of a miniature, right? So what connects the two of these is something that we call a scale factor. Sorry, the pen is being a little sloppy today. Right? What connects them is a scale factor, right? So this is going to be a number that we multiply by to get our result. So if we want to enlarge something, for example, we would multiply by like 2, right? You would say like 2 times larger, right? Or you would say 3 times larger or 10 times larger, right? We can have any of these numbers. It's also possible to shrink, like we see here, right? This is um, again our original is this larger hippo, and then we have kind of B being smaller. Our scale factor can also be a fraction less than 1, right? So for instance, 1/2. So it becomes half the size that it was before, or a third the size, or a tenth of the size, right? We can scale down that way. But it's about multiplication, right? So we always are multiplying, going one from the original to the next. So the way that a dilation works kind of is almost like something that is kind of expanding and contracting, right? So we can kind of see how it kind of has this vanishing point here at the end, right? And we can use these guidelines to kind of draw, smaller and smaller figures, right? So for instance, like what we see up here, right? So this was, let's say, a scale. Let's say we do a scale factor of 1/2, for instance. Let's say this hippo is exactly half the size of the original. So we could do that with kind of our snowman. And the way that we would do this is by taking every point and bringing it half the distance back to where it was before, right? So we could have, this would be, for instance, D prime. We could have B prime. We have A prime. Right, we draw it back. And we can start to see sort of this idea of where these points are going to lie, right? Not perfectly, but again, if we wanted 1/2, right, it would be half the distance there. And again, it pulls back to some sort of common point. Okay. Um, Now, what does that look like in practice, right? So we're just kind of getting used to this, just this right here. So let's look at some like IXL example problems. Okay. So a couple of things to keep in mind off the bat. Sorry, trying to get this here. Is when you answer, right, make sure to write a simplified answer. You can write it as a proper fraction or an improper fraction. So that just means um, the number on top of the fraction can be either smaller or larger than the denominator, or it can be a whole number. So basically, this just means write a fraction or a whole number, right? No decimals. So it says here that we've got trapezoid f prime g prime h prime I prime is a dilation of trapezoid f g h I. So the one that has the parentheses is the end result. The end result. So in this case, that's the orange, right? The orange has our parts, right? So what is going on, right? Is you first ask yourself, is the transformation resulting in a smaller image? And the answer is yes, right? It's getting smaller. So we're going to expect a fraction in this one. Again, it's going to be a certain size. Okay. So if this is a dilation, then and I think all of these problems are going to have the center of dilation be the origin, right? So we don't have to think about this in too much of an advanced way. All we need to do is really find a pair of corresponding points, and we can kind of figure out what the dilation is, or we can use any side of our figure and figure that out. Again, this is something that we can do. What I see here is this side right here is 2 units in length. And that's the same as this side here, which is 4 units in length, right? So what do I multiply by? 4 times my scale factor equals 2, right? So what is happening here, right? So I have to multiply my original times the scale factor to equal 2. Again, I can solve for this. S here is going to be 2 over 4, which is the same thing as 1/2, right? So my answer here would be 1/2 because the orange image is half the size of my green original. Look at another example here. Same rules. Okay, same rules. So we can even do the same type. I'll try one with coordinates this time. This gives you just a different way to see it. Again, there's multiple ways that we can kind of think about this. But when I look here at this problem, again, it says we have triangle L prime M prime N prime and LMN. This time, the big triangle is the result. And I can tell that I can see L prime up here. Again, that tells me that that is the end result. So this is, we're going to expect an answer that's bigger than 1, right? So most likely, it doesn't mean it's not going to be a fraction. It doesn't mean that, but it does mean that the answer is going to be bigger than 1 because it's got to be more than 100% or more than itself. So I'm going to do this with a coordinate. So I'm going to see L. So coordinate L is x equals 2, y equals 2. So that's coordinate 2, 2. L prime, which is after the dilation, is at 8, 8. Right, so this is kind of nice because you can see the relationship between the numbers. Again, it should equal the same. So again, what we're looking for is 2 times s is equal to 8. Right? Sorry, this is really sloppy. Right? So again, 2 is the original. I multiply it by my scale factor and I get 8. Again, that means that S is 8 over 2, which is 4. Right? So the big triangle is actually 4 times the size of the original piece.